All right. So we are live right now. Welcome back. So I hope you're all doing wonderful. So welcome back to this amazing platform. Okay. So I hope you are have understood what we have discussed in our last class, right? So as of the last class, we have already finished discussing about the addition of vectors, right? So if you have been new to this particular platform, I would request all of you to please go back to the channel description and you can find out all this lecture that has been taken so far, especially on the topics of vectors, okay? And apart from vectors, we have already finished the calculus portion for the JEE Mains and Advanced upcoming year, right? So you can watch those particular series of lectures to basically get an understanding, and with that you can also start with the preparation. Okay, so if you are looking for quality contents, definitely you are on the live platform. So with this, I would request all of you to please subscribe the channel and hit the bell icon so that whenever we are live on this particular platform, you get a notification. Okay, so let's start with today's discussion. And today we're going to discuss about the properties of addition, and then we're going to solve some general questions. Okay, some general questions regarding the vectors addition and subtraction, right? All right. So let's before we start, I would request all of you that if you are interested into joining the online one-to-one batches, you can definitely contact us on this particular number that is given on the screen. So you can contact us on this number to get mentorship or live doubt clearance or anything like that. So you can obviously contact us so that you can get access to our one-on-one batches. Okay, and from there you can ask me any doubts or any confusion regarding our syllabus preparation and anything else. Okay, so with this, let's start with today's discussion. Okay, so let me first start with the properties about vector addition, right? So let us go about with with properties of vector addition and vector subtraction. All right. So what are the different properties regarding vector addition and vector subtraction? Let's try to see. Right. So if you recall that in our last previous discussion, we seen that vector subtraction is nothing but just an addition of a negative times a vector, right? And what is negative vector? So whenever we multiply minus one is a scalar. So whenever we multiply any scalar to a vector, the magnitude of the vector gets changed, right? However, the direction of the vector remains the same. For example, if I have, let us say, this is my a vector. Okay. Now, if I want to write what is the value of 5a vector, then I'm going to represent the magnitude of the vector a to be increased by 5 times the magnitude of vector, that is vector a, right? So but what you notice is that the direction of this vector remains the same. Okay, so whenever we multiply any scalar to a vector, the magnitude of the vector changes, however the direction of the vector remains the same, right? So this is one of the basic concepts to understand and that we have discussed in our last class, right? So therefore, from this understanding, we discussed that the negative of vector basically means that we are multiplying -1 to a vector, right? So that is basically multiplying a vector with a scalar, that is scalar is minus of 1, right? So now, also one more important thing to note as a property is that now vector subtraction is not commutative in nature. That means that if you have vector A minus vector B, it is not same as vector B minus vector A. Okay, so this particular thing does not hold true. All right, so you have to understand this particular thing that it is not the not exist for the vectors. All right. Along with that, it is also very important to understand that the distributed law can be given as is not equals to like a minus b vector and then minus c vector, right? So what is most important to understand is that in vector addition or vector subtraction, the direction actually matters, right? So when you are subtracting b minus c, you might end up getting another vector, and then you are subtracting a vector minus that particular other vector, it might end up getting any another kind of vector, right? Whereas when you are subtracting a vector and b vector first, and then you are subtracting from c vector, you might have end up getting different results. Okay, so please note this particular thing so that you can get with started with questions. Okay, I hope this idea is clear to all of you, right? All right, now one more thing that is basically regarding the inequality. Okay, that is relating the inequality, okay, so one more thing is relating the inequality. All right, so now, we have already seen this triangular inequality, that is, the sum of any two sides of the triangle is obviously greater than the third side, right? Also we have seen that since any of the side of the triangle is obviously less than the sum and greater than the difference of the other two sides. So for any vector, I am in a position to write the inequality as a vector minus b vector, and mod of that is less than or equals to mod of a vector plus mod of b vector, right? All right, so, oh sorry, this is a vector plus b vector. Okay, so a vector plus b vector mod is less than the individual mod, okay, or sum of the individual magnitude. I hope this is clear. Similarly, we can write the other results as, that is, a vector plus b vector, and mod of that is greater than a vector minus of b vector, like this. Okay, so it is greater than like this. And also for the negative of vector, we can write a vector minus b vector, and mod of that is less than or equals to mod of a vector plus mod of b vector, and it is obviously greater than. So I'm clubbing this in this particular inequality and writing as, it is obviously greater than a vector mod minus of b vector mod. Okay, so this is my third result. Okay, I hope this inequality is clear to all of you. Okay, this is just simply from the taken from the triangular inequality. Okay, all right, I hope this is clear to all of you. Okay, all right, now regarding the multiplication of a vector by a scalar, there are certain more properties that we also need to remember, okay, or relate to. Properties of multiplication, okay, so properties of multiplication of vector by scalar. So let's try to understand the properties of multiplication of vector by a scalar. Okay, all right, so let's try to understand what are the properties of the vector multiplication by a scalar, right? So there are certain properties in terms as that if I multiply the scalar m with negative of a vector a, then this can be equivalent to negative of that scalar m multiplied with that vector. Okay, I hope this is clear, right? And similarly, we can have certain more properties as, so if I multiply negative of a scalar with a negative of a vector, then this is basically equals to positive of the scalar multiplied with that particular vector. All right. And if I have m into n times of scalar, n is a scalar and m is a scalar times of vector a, this can be given as n into m times of vector a, which can also be given as n into m times of vector a. All right. And similarly, the last result, which can also be given as, that is m times vector a plus vector b, can be given as m times of vector a plus m times of vector b. All right. So these are the four important properties regarding the multiplication of vector by scalar. All right. I hope this particular part is clear to all of you. Is this part clear? Is this part clear to all of you? Is this part clear to all of you? If you have any questions, please let me know so that we can discuss about it. All right. So these are the certain properties of regarding vector multiplication by a scalar. Okay. So I hope you can relate to these properties. Okay. All right. So with this, let's now understand about another important thing, that is basically resultant, or what is the magnitude of resultant of two vectors. Okay. So let's discuss about that particular thing in detail. That is resultant of two vectors. Okay, so let us discuss about the resultant of two vectors. Okay, so let's discuss about the resultant of two vectors. Okay, so what do we actually mean by resultant of two vectors? What I'm trying to discuss is that, again, we've already seen that how we can add two vectors, right? But now we didn't see that how we can calculate the magnitude of vector addition. So what I'm going to do over here is that I'm going to calculate the magnitude of vector addition, or addition of two vectors, right? So how am I going to do that? So let us take, I have a vector A like this, and I have another vector B like this. Okay. Now I know that vector addition can be performed by completing this parallelogram over here, and this diagonal would represent a vector plus b vector. Okay, and this diagonal would represent a vector plus b vector. Now I'm going to explain you one more concept, that is basically called as angle between the vectors. Okay, angle between the vectors. So let's try to understand what is meant by the angle between the vector, and I'm calling it as theta. Okay, so what is basically meant by the angle between the vector? Let's try to understand about that so that we can do this derivation. Right. So if I have two vectors, the angle between the two vectors is defined such that, if I have two vectors, the angle between the vectors are defined such as the angle that the vector is forming at their intersection of the tails, or at their intersection of their head. So if I have two vectors like this, I must form the intersection at their head or at their tail. Okay, so the intersection should be done at their tail or at their head. Okay, so whenever I take the intersection at their tail or at their head, whatever is the angle that is formed by the vector, that particular angle is therefore defined as the angle between the vector, right? But please note that you might also have a situation like this, that your vector is given like this. Okay, and they might, to confuse you, they might give you this particular angle as theta. But you have to be cunning enough to understand that this angle theta is not the angle between the vector. What you have to do is that you have to bring this particular vector, over here, and then you have to calculate, this particular angle, which can be given as pi minus theta, because this is basically the straight line. So pi minus theta. So therefore pi minus theta is now going to be the angle between these two vectors. Okay, so please note this particular difference. So whenever we talk about angle between vector, we refer to the angle that is formed by the vectors at their tail, or intersection of the tails, or intersection of their heads. Okay, so this is a very important concept. Now let us try to apply this over here. So if I look at the resultant of the vectors over here, what I can notice is that Now let me say that over here I get the angle between the vector which is given as theta over here, right? And they are basically meeting at their tails, so therefore this is theta is the angle between vector A and vector B. All right. Now, in order to find the magnitude of this particular line, that is this diagonal line, so let me first of all name this parallelogram, that is ABCD. All right. Now, in order to find the magnitude of the line segment AC, what I'm going to do is that let me think of that I'm going to put or drop a perpendicular from C on the straight line AB. Okay, on the line AB, and let us call this point as E. All right. So in this case, what I see is that I'm trying to do this construction, right? Now, if you recall, that is a parallelogram, right? So the angle of the corresponding side of parallel lines are basically equal. So this angle is also going to be theta, right? Now this particular vector is also will be the same as the B vector, right? Now if I ask you two components, that is the BE component and the BCE component, the answer is very simple, like we saw in our last class, that this projection, that is a BE and the EC, these two projections length will be equals to, so BE length will be mod of B vector cosine of theta, and similarly this EC length is going to be mod of B vector into sine of theta, right? So these are the magnitude of the perpendicular and the base magnitude, right? Now if I complete this magnitude, and if I talk about this particular triangle, now if I talk about the triangle AC and E, you will notice that it is a right angle triangle. It is a right angle triangle. Now in a right angle triangle, I can apply the simple Pythagoras theorem. So in triangle AEC, the angle E is basically 90-degree, right? So therefore, based on this 90-degree angle, I can write the Pythagoras theorem as AE square plus EC square is equal to AC square. Now, if I am able to find out the value of AC square, this AC square or AC is nothing but the magnitude of the A plus B vector, right? So if I am able to find out this particular magnitude, then I am able to find out the magnitude of the addition of two vectors, right? Or the magnitude of vector addition. So over here, then if I try to find out AC is going to be mod of A plus mod AE is going to be mod of A plus mod of B cosine of theta and whole square of it, plus now EC is going to be mod of B into sine theta and then square of it, right? So if you just evaluate this expression and you complete this particular thing, so you will see that your AC expression is going to turn out as mod of A square plus mod of B square plus 2 times of mod of A into mod of B into cosine of theta, right? So this is going to be the result, and this AC is nothing but the mod of A vector plus B vector. So ultimately what you will see is that this particular formula will generate you the result for the magnitude of addition of two vectors. So if I have two vectors, A vector and B vector, and if I try to find out the magnitude of the A vector plus B vector, that is going to come out as square root of mod of A square plus mod of B square plus 2 times of mod AB into cos theta. I hope this result is clear to all of you. And you must have seen this result, especially in physics as well, right? So you must have used this particular result in physics to solve many questions, right? I hope you can understand this part. I hope you can understand this part. Is this part clear to all of you? Please let me know in the live chat. Is this clear or not? Is this part clear? All right. So I assume this part is clear to all of you. All right. Now, another question can also be there in terms that what is the direction or what is the angle that this summation of these vectors, A vector and B vector, is making with any of these vector or maybe with the A vector, right? So if you now come back over here, again, if you follow this triangular notation, in this particular triangle itself, or this small triangle ABC, what you can see is that if I calculate this particular angle, let us call this angle phi. So this phi angle is nothing but the angle between the vector A and vector A plus B. So if I'm interested to know about, so if I'm interested to calculate, which I am, so calculate the angle between the vector A and the vector A vector plus B vector. So if I'm able to find out, this is basically equals to phi. Now how am I going to find phi over here? Hi Rashmi Pia, are you able to understand this? All right. So how am I going to find out phi over here? So to find out phi, I'm going to use the trigonometry over here, as I am going to find the tan of phi and the right angle triangle. So tan of phi is going to be this particular perpendicular upon this base. So the perpendicular is mod of b sine of theta plus divided by mod of a plus mod of b cosine theta, right? I hope this is clear to all of you. All right. So from here, I can find out phi as tan inverse of mod of b sine theta, tan inverse of mod of b sine theta divided by mod of a plus mod of b cos theta. Mod of a plus mod of b cos theta. All right. I hope this result is clear to all of you. Okay. So this result is clear. So this result will generate you the direction or the angle by which the addition of two vectors is basically inclined or is making with the a vector. Now in the same way, you can find out the angle between the b vector and a plus b vector, that is over here as theta minus phi. So depending on the question, whatever is being asked, you can find out the final result. I hope this is clear to all of you. I hope this result is clear. Is this result clear to all of you? Is this result clear? All right. So I hope this result is clear. And with this, we can go about to discuss about our next upcoming topics. Also, based on this particular idea, even we are going to use this particular concepts to find or in our dot product, right? Or multiplication of two vectors. Okay. I hope this is clear to all of you. Is this part clear? Okay. So I assume this is clear. So let's now discuss some of the problems. Okay. All right. So let's solve some questions. So let us say if I have a hexagon, in a hexagon A, B, C, D, E and F, right? So hexagon is a six-sided figure or a six-sided regular polygon. So let me draw the hexagon over here. So this is a hexagon, right? And let me name it as A, B, C, D, E and F, right? So this is the hexagon, right? Now it is said that you have to find out. So it is a regular hexagon, okay, where the side length are same. So it is a regular hexagon where the side length is same. Now you have to find the value of AD vector plus EB vector plus FC vector. Okay, so you have to find this vector summation of AB vector plus EB vector plus FC vector. That is your question. Okay, so please try to solve this problem. Please try to solve this problem and try to represent this in terms of AB vector. Okay, some constant multiplied with AB vector. So please try to find out that value of that constant. Okay, try to represent this particular summation in terms of the sum of AB vector. Okay, so please try to solve this problem. Please try to solve this problem. Please try to solve this problem. This is a pretty interesting problem. So please try to solve it and let me know the answer in the live chat. Vaishnavi, hi. Please try to solve this problem. All right. So let's try to see that how we can solve this problem, right? So it's a fairly simple problem. Now, if we look at whatever the sum is given over here, if we try to look at the sum that is given as AD vector plus EV vector plus FC vector, right? That is basically the sum that is being asked, right? So if I look at AD vector, now I can write AD vector as sum of AV vector plus BC vector plus CD vector, right? I can write like this. So I'm going to write like this over here. So AB vector plus BC vector plus CD vector, that is what I'm writing as AD vector, right? And similarly, EB vector, I'm going to write it as, similarly, EB vector, I'm going to write it as ED vector plus DC vector plus CB vector. Okay, I hope you follow the direction as well, right? So just by using the polygon law, I'm writing this. And similarly, FC vector can be written as now I'm not changing FC vector, okay? So let me write FC vector as it is, okay? So let me write FC vector as it is, right? Now you will see that there is a very interesting way to solve this problem. And this is basically what is the pure part of the vector algebra, right? So to think of that how we can manipulate these answers, okay? So I need the answers in terms of A vector. So let me keep A vector as it is, right? So if I analyze this BC vector, so if I analyze BC vector plus CV vector, okay. So if I analyze this BC vector plus CV vector, they are basically negative of each other and they will get cancelled out. Okay. So BC vector plus CV vector, they are basically negative of each other and will cancel out. Similarly, if I have CD vector and DC vector, again they are opposite of each other and will cancel out, right? And I will left out with ED vector plus FC vector, right? Now again, if I look at this particular diagram, now ED vector plus FC vector, ED vector, now, if you recall that ED vector is nothing but, now since it's a regular polygon, so ED vector is the same. So because the magnitude of AB and ED is same and the direction is same, so ED vector is nothing but it is same as AB vector. Okay, so ED vector is same as A vector. But on one more thing is to notice is that FC being one of the diagonal. Now you know that in regular polygon, this all the side length, these particular sides are equal and this particular angle is 60 degrees. So they are basically making an equilateral triangle. Similarly, by that particular thing, you can see that FC vector will be just be equals to 2 times of AB vector. Okay, so FC vector will be equals to 2 times of A vector. So therefore, if you add this all vector, you are going to come out get the result as 4 times of A vector because FC is also going to be equal to 2 times of A vector. So therefore, the sum of the required sum of the vectors is going to come out as 4 times of A vector. All right. So therefore, this particular constant that you're trying to find it out is going to be equal to 4. I hope this result is clear to all of you. right? I hope this result is clear to all of you. Is this result clear? Is this part clear to all of you? So this is how we solve questions regarding the summation of vectors. Okay. So I hope you can try to solve these kinds of problems more so that you can understand, these kinds of problems. Okay. So maybe you can check out your previous year JEE mains problems and you can find out a lot of different types of problems on this particular type especially. Okay. So I'm not discussing this kind of problems. Rather, we will start to discuss about certain more properties and regarding position vectors. Okay. So in our upcoming lecture, we are going to discuss about the properties regarding the position vector, or how we can find out specific position vectors or specific position on the triangle using the position vectors concept, right? Like that of the section formula, like that of the centroid or off center of a triangle, right? So if I represent all the points of the triangle by some position vector, now in terms of those vector, how am I going to write the vector, and then how I'm going to write the position vector for the centroid, for the off center, for the circumcenter, and all those particular things, right? So all those things I'm going to discuss up in our next class, right? So that is basically geometry oriented. So it will be wonderful if you could have revised the part of coordinate geometry. Okay. So I would request all of you to please go back and revise the coordinate geometry part so that you actually have an idea on how to solve those kinds of questions. Okay. And then we will be also solving some of the previous year JEE mains problems as well regarding the types of topics that we have already covered, right? So that will be all that we need to finish up, especially in the basics of the properties of vectors and then addition and subtraction of vectors, right? And after that, we are going to move towards understanding about the multiplication of vectors and multiplication of three vectors as well. Okay. So those will be the upcoming topics. So I hope you enjoyed watching this session as much as I did in discussing these particular ideas. So I hope to see you up in our next lecture, and please subscribe to the channel and also hit the bell icon so that whenever we are live on this particular platform, you get a live notification, right? So and then in that particular live class, you can always ask your questions, you can ask your doubts or anything that you actually have issues with. Okay. So with this, I would like to conclude the session over here, and I hope you enjoyed solving these types of questions. Okay. So there will be lot of more these types of problems will be coming up. Okay. And in our next lecture. Okay. So for that, please follow and subscribe. All right. And share these videos with your friends as well as your juniors as well. Okay. So that they also get an advantage of these live lectures or these free live lectures. Okay. So with this, thank you for watching and I wish you all the best.